Hello everybody, this is going to be our Algebra 2 Essentials in Algebra, unit, lesson 1, homework review. And for all those who are new to our channel, this is just going over homework questions from a lot of these lessons here. And so this is our first review for our first lesson. A lot of you have already seen a lot of this. This is a review. But very important to understand these concepts. So hopefully we'll get through these pretty quick. If you have questions, leave them in the comment section below. And any comment feedback would be great as well too. Okay, and of course, give the video a like if it is helpful in any way possible. All right, ladies and gentlemen, here we go. For question number 1, for each of the following expressions, state the number of terms. Okay, so these are algebraic expressions, and how do we know that they're algebraic expressions, not equations? There's no equal sign. If there was an equal sign, then you have an equation. Here we call them expressions. And they're algebraic because we have what's called variables, which are letters, in place of numbers. And so algebraic expressions. And so here we go, 3x squared minus 1. Now the number of terms can usually be told, we can figure out as, in this case, how many addition or subtraction signs there are, because terms are either adding or subtracting each other. So for example, for number 1, question A, 3x squared minus 1, there are going to be 2 terms. And so why? Because here you have 3x squared is one term, and 1's another. And what combines them is going to be a plus or minus. So we have 2 terms for this one. Okay, now for B. Well, B we have 8x plus 7x squared minus 2 plus 3x. And so here we have 4 different terms. Because here we go, 1, 2, 3, 4. These terms are separated from each other by an addition subtraction sign. Notice that 8x is a single term, even though it is really the operation of 8 times x, which is a single term. Therefore, these are 4 terms. And finally, for C, we have 7xy minus 2x squared y squared plus 1/2 xy fourth. The fraction in the scale is just another number. This is another number multiplying. And so we have here 3 terms. Okay? Here we go. Simplify each of the following expressions by combining like terms. Be careful to only combine terms that have the same variable and powers. Now, like terms, let's go over a definition here. In algebra, like terms are terms that have the same variables and powers. So they're not only just the same exact letters, they have the same exact matching exponents. The coefficients do not need to match. Unlike terms are 2 or more terms that are not like, meaning they don't have the same variable or powers. So unlike term, an example of unlike term would be in this case 3x squared and 4x. You might say, well, how come they both have x? But 4x is only x to the first power. They have different exponents. Because the exponents are different, they are not like terms, even though they're the same exact variable. Another example of unlike terms would be 3x squared y and 4x squared. Now this time you say, well, what's the big difference? They'll both have x squared, except the first term has the letter y, the variable y multiplying, and the second term does not. They must match. To make these 2 terms like terms, you must have the same exact variable with the same exact matching exponents. So 4x squared y would be a like term to 3x squared y. Let's go back to our question number 2. And we see in this case we have 2x squared plus 8x minus 1 plus 5x squared minus 2x minus 8. Now, what I like to do is circle like terms together. So here I see a 2x squared and a 5x squared plus 5x squared. And so those 2 terms are like terms. I'll see a plus 8x and a minus 2x. Those are both like terms as well because they have the same variable x and the same exponent. And finally, I have the constants -1 and -8. So we're going to add the like term together. So 2x squared plus 5x squared is 7x squared. 8x minus 2x is minus 6x. And negative 1 minus 8, I think it's minus 8, is it? Yes, minus 8. Negative 1 minus 8 will give us minus 9. And this will be our expression combined. Okay? So if you have colored pencils or pens, you can do that too. Circle them separately. Or if you want to, we can put different shapes. For example, circles for the x squareds, rectangles for the x's, and triangles for the constants. So we would have in this case negative 5x squared minus x squared would be negative 6x squared. We would have in this case minus 2x plus 7x is equal to plus 5x. And then we have in this case, I just want to make sure, that's a plus, okay, to make sure, yes. All right, so the plus 10 plus 5 is going to be plus 15. And this would be our combined expressions, okay? Now C is a little bit tricky, okay? So we're going to use colors again. So we have 4x squared y minus 2xy squared plus 9xy squared minus x squared y. So now they both have x and y, but they have the exponents a little bit differently. So here we have the 4x squared y, okay? Erase this a little bit. You know what? Instead of circling, let's underline them. That might be a little better. Okay, so the 4x squared y and the 9, oh, not that one, minus x squared y. So notice in this case that we had to make sure that they matched. So the 9xy squared would not match up with the 4x squared y. Instead, the negative 2xy squared would match up with the 9xy squared. And so here we would get 4x squared y minus 1x squared y. Now you're saying, where's the 1? Well, we subtract minus x squared y, it's really minus 1. So we would have 3x squared y, and then negative 2xy squared plus 9xy squared would be plus 7xy squared. Okay, and then finally, we have in this case, ooh, this is a tricky one, okay? So I'm going to just basically look around for which terms match up. So I have a 7x squared. And so not that one, not the minus 2x squared y, not the same, not the 4xy squared, not the negative y cubed, but the 2x squared, okay? And then that's it, okay? Now what matches up with the negative 2x squared y? Looking for x squared y. Oh, there goes the 9x squared y. Okay, and then we also have what matches up with the 4xy squared. Nothing. Okay, so we have now in this case. Oops, we use a little blue there. Oops, blue. Okay, so the minus y cubed and the plus 4y cubed. All right, so let's put this together. So 7 plus 2 is 9x squared. Oh, maybe you should use the matching colors. Yeah. Okay. So that's 9x squared. And then, of course, for the minus 2x squared y and the plus 9x squared y becomes the plus 7x squared y. All right. Now, that 4xy squared just stays by itself because not like terms cannot combine with anything else. And finally, we have in this case the minus y cubed plus the 4y cubed is plus 3y cubed. Okay, and so this will be our combined terms together. We gotta be super careful. I know it seems like in this case that it's very easy and straightforward. In some ways it is, but it's also very easy to make errors when trying to put these stuff together. Okay, all right, so let's do question number 3 at this point. So, all right, given the algebraic expression 12x plus 12 over x squared minus 1, do the following. Evaluate expression when x equals 7. So we would have 12 times 7 plus 12 over 7 squared minus 1. And so 7 times 12, 84, plus 12 is going to be 96. And 7 squared is 49, minus 1 is 48. To simplify this, however, we get 96 over 48 becomes 2 over 1. Okay, now, is there another way to do this? That we can plug in, not a big deal. But one of the things we can also know how to do is factor, okay? The greatest common factor for our numerator here would be 12. We'd have 12 times x plus 1. So this is kind of a reverse distribution, okay? And as we multiply 12 times x plus 1, we would get 12x plus 12. And if you factor x squared minus 1, we would get x plus 1 times x minus 1. And the funny thing is now with all factors here, we can simplify and we would just end up getting the x plus 1s dividing out. And we should get, in this case, we will get 12 over x minus 1. So we can evaluate this way too. So here, if we were to work on this with the original problem, 12 over 7 minus 1, we would get 12 over 6, which is still 2 over 1. And we use 4, we have 12 over 4 minus 1, we would get 12 over 3, which is equal to 4 over 1. So Neapoli's expression is equivalent to dividing 12 by 1 less than x. Well, do they support? And the answer is yes. 12 divided by 1 less than x. This is what we call the factored expression. And so yes, if we factor and simplify, we get the same expression, except for one thing. And here is the big deal. Except, okay, and I'll type this out because my handwriting's getting worse. Okay, so make sure I have the right font. Okay, except we cannot use the values. We cannot use the values of x equals 1 or x equals -1. Okay? These values would make the denominator of the, denominator, sorry about that, denominator of the original expression undefined, equals 0 actually. Equal to 0, making the expression undefined. So this is one very important thing we want to stress. Even though we can factor and simplify, we will end up getting a situation where, hey, we have a limited domain, okay, a very restricted domain in this case, okay. All right, so this is questions 1, 2, 3, and this will end part 1 of our homework review, and hopefully this is somewhat helpful. Again, some of these things are like, well, I can figure this myself. Just understand in this case that if you try to plug in -1 into our expression, you would probably get 0. You would get a 0 over 0 situation, which is still undefined. Okay, and so we don't get to those types of things until we get to calculus, which is a little bit away from now. All right, ladies and gentlemen, hopefully it's helpful to you guys, and look out for part 2 of this homework review. Hopefully it'll be helpful to you guys, and I look forward to seeing you in the next video. Don't forget to give a like. Take care, guys. Bye.